Right. Um, Hi there, and welcome back to our course in ABE161. And here in this video, we will discuss another type of connection that's common to a steel structure, and that's the welding or welded connections. So, just like what we did in the bolted connections, where we discussed the overview, then the types, then um, in the end, we discussed the code provisions and some uh, derivations. So that's what we are also going to do here in the welded connection. To start, we'll start our discussion with this welding. Or let's define what uh, what is welding. Welding is a process of fusing materials by melting the edges and often adding molten filler material um, or filler metal. To illustrate this, let's have a section of a plate. For example, we have two plates here, and or let's just draw a lap splice. Okay, so we have, let's say, two plates, and for a bolt, what you're actually doing is you're drilling a hole, and then you are inserting a bolted nut. But for welding, it is just actually melting this metal and then melting this part as well, and then they're actually in some way they are bonded together or fused together because it is actually heated up, so they melt and then they they bond together. So in that way, somehow there is a strength in that type of connection. Now let's discuss some advantages and then later on the disadvantages. For the advantages, we have number one, we have flexible configuration. We have flexible configurations. As we have discussed in the bolted connections, that you can actually weld any type of um, configurations as compared to the bolted ones, because there are situations wherein you cannot drill holes and you cannot insert this bolt. So in that case, probably in tubular, let's say, bars, now you can actually just accommodate this bar to be welded with this bar or with this tube without any need of a cassette plate. Okay, so that's provided. Assuming that we have enough weld length. Okay, and let's say here, another one here, then another one here. Okay, so for welding, it has a flexible configurations. Number two, we have more tolerance with misalignments. Okay, so since we're not actually drilling holes or we are not actually inserting or aligning the holes between the plates, then these this bolt as well, then we have a wide range of tolerance for these misalignments. Whereas for bolted connections, you have to take care of the misalignments. You have to be more accurate or let's say more precise. Now the third advantage is it takes up less space. Okay, so just like this, it has less space and less materials, because if you wanna do it with a, let's say, with a bolt, then you have to actually probably do the or check the spacing of the bolts and things like that. And also, plus there's a bolt material itself with the bolted connection, then it's actually um, adding adding materials. Whereas for welds, it's just less space and less materials. The number four is it has smooth and cleaner appearance. Okay, so for the disadvantages, it requires skill. So welding, you have to hire, of course, a welder that's actually trained, and it can or that can provide proper weld joint. Because if not, then the joint um, will not be strong enough. So you have to provide a proper penetration of the weld. Now the number two disadvantages or disadvantage is it has more time to uh, to or more time in field erection. So meaning that once the beams and the columns arrived in the site, and you're going to erect it, then of course by connecting those beams and columns, then you you are having much time in this field erection as compared to boltings. Because in boltings, although it requires holes, these holes, they are actually they can be fabricated, not on site. I mean, they can be fabricated on a shop, and then it's just being installed in the field. Okay, number three, inspection of weld. As what I've said, that welding requires a proper penetration between these materials. Now, so therefore, the inspection of the welded joint is extensive as compared to the bolted joints. The fourth one is distortion of members. As I have also mentioned in the topic of bolted connections, that once you're actually heating up this part, let's say we have this joint, lap splice joints, and once you're welding this, you're actually heating this portion, and of course there's going to be a gradient. This portion is hot, but this one is let's say it's cold. So what will happen if you have a temperature gradient here? Then uh, we all know that I mean, we have learned in the strength of materials that when there's ever a temperature change, then it can also induce stresses. Okay, so and that stresses is, let's say, you can relate it to the deformation or movement of this part. Okay, so meaning that this part is, let's say, it wants to go in compression, while I mean, see, it's hot, and let's say it's in tension. This one is in tension, and then this one is in compression. So there's actually a result into a um, distortion of members. So instead of having it straight, it's like uh, probably something like this. Okay, so that's the disadvantage of welding. So in that case, you have to provide proper bracing, or you have enough material to be able to accommodate this um, distortion. Okay, and the last one, we have these residual stresses. Okay, so residual stresses, like it's like something like this as well. But let's say we have this beam, and this is our um, column. So we first, let's say, we we install a seat here, and then we weld. Okay, weld. Okay, and then we weld for positioning. Okay, but after that, let's say it is required um, to have the joints full weld. So meaning that if this is our beam, so it has to be welded here, and welded here, and every joint's the same. Okay, so once it is welded and this beam is already restrained, then meaning that it's actually inducing stresses here. Okay, and as well as here, because there's a temperature. If you weld here, there's going to be a temperature increase, and therefore it's going to be related to the expansion of the material. But since it is constrained, then it cannot displace, and therefore the result will be the residual residual stresses. So meaning, even though it's already erected that way, and in our analysis we just assume that it's just having some weights here, or let's say downward force, but the truth is there are stresses in here already, even without the presence of the occupants yet. Okay, so that's the concept of the residual stresses. Okay, so now let's discuss the um, or let's go to the introduction of our lecture handout, and it just says that welding is a process of fusing materials by melting the edges and often adding molten filler metal. And the American Welding Society, or AWS, they're the ones developing the codes and recommended practices and guides. And the Structural Welding Code is one of the most consulted codes in the world. American Welding Society. Now let's discuss the four types of welding process recognized for structural use. Take note of the statement: four types of welding process recognized for structural use. We have number one, the shielded metal arc, and number two, we have the gas metal arc welding. This one is the flux core, and this one is the submerged arc welding. Okay, so shielded metal arc, this is what we're going to discuss it here on. Consider that this is actually referred to as, or commonly referred as, the stick welding, because there's actually a presence of electrode. Now in a shielded metal arc welding, let's say this is our um, material, and we are actually joining this material through this fillet weld. In order to produce this weld, there's actually an electrode, and this electrode is connected to a, let's say, electrode holder. Or we'll draw another one here. Let's say this is a plate, this is our metal. So let's say this is our joint, and to join this we have these electrodes, and this electrode is connected to a holder. Then this holder is connected to an electric machine, electric welding machine. And then there's a positive one here. I think this is the positive, and the negative, the ground, it's being clamped on the workpiece. Okay, so in that way it's actually, it can produce an arc over here. Okay, so now let's discuss the types of weld. For the types of weld, we have fillet welds, we have groove, and we have slot and plug welds. Three. Okay, so let's discuss in detail these types of weld, and take note, here we are referring to the types of the welded joints, whereas the other ones that we mentioned earlier, those are the types of the welding process, where the shielded metal arc is one type. But here we have, we'll discuss the types of the welded joint. Now for a fillet weld, if this is our section, or let's just draw in 3D. Now the fillet weld, it's actually the shape of that is actually something like a triangular shape. Okay, so you're welding as it is without any cutting any groove, or let's say groove preparation. For groove welds, it's like this. Now if we want to join this these two materials together, then we have to cut, let's say we have to cut a groove here. Okay, and then in this groove you are going to weld it here. So that's why it's called groove welds, because you're actually cutting grooves. Whereas here for the fillet welds, it's not. And this plug and slot weld, okay, let's draw in 3D again. For the slot and plug welds, you're actually drilling a hole or a slot so that you can provide the weld in that slot or in that hole. Okay, so again, fillet welds is something like this triangular shape, although there are still other kinds, I mean types of how you would do these fillet welds. But for now, let's just say that it has something like this. And for the groove welds, you're providing a groove for the welded joint. And then for this one, the slot and plug, you're just making holes or slots so that you can weld in that hole. Okay, so this fillet weld, this is probably most widely used, and it has economy. Why? Of course, you don't have to do any preparation as compared to the groove welds. This you have to make a groove, but this one you just have to lap each other, or to attach each other. And this one can also be this in these configurations, let's say in a perpendicular configurations. So you can do that. Okay, so for the groove weld, it requires actually spacing here. So it has some required spacing and um, other details. And for plug and slot weld, they're actually used when, let's say, when this weld length over here, let's say you have provided a fillet weld here, and then let's say the weld length is not yet enough, then you can provide, let's say, a plug and slot weld over here, just to increase the weld length. Okay, so now let's discuss the weld symbols. Okay, so we have this basic weld symbol, an arrow line that looks like this, and we have this symbol right here. And let's say we have a number here, let's say 8, and then this one is, let's say, 100. Okay, so this symbol here, uh, specifically this this triangular symbol, it's actually the weld symbol for fillet. Weld symbol for fillet. And this one refers to the weld size, and this one refers to the weld length. Okay, and this is our reference line, and this one is the arrow. Okay, so the arrow, it actually points to a location that should be welded. So for example, we have this configuration, and we want to weld here. So if we want to weld here, then the notation should be this. Okay, so this is the arrow, and then this is our reference line, and this is our weld. Now, if we have an let's say if the weld symbol is outside, then it means that that the welding is on the other side. So meaning that's here. And of course, when you say when you specify, let's say 8, then this one is um, this is 2 or 20, or let's just say 200. So meaning that we have an 8 mm. So let's say this is our weld. So the 8 is actually this one, the size. And for the weld length of sorry, I think this should be on the left, and then this one on the right, 200. So we say 200 for the length, then meaning that this length should be 200 mm. Okay, so I think that's all we need to know for now, because that's just the typical symbols that we'll encounter in our homework. Okay, so 8 meaning that it refers to the size, and this one 800, I mean 200, and that's the weld length. And this fillet, this symbol is the weld symbol, and if it is present on both sides, then it means that both sides will be welded. And also, um, this will be for an equal, let's say equal size of fillet weld, then this will be also the 8 mm. Okay, so now let's move on to the welding electrode. Okay, so welding electrodes, uh, they they actually come in different types and also sizes, and each type will have a specified strength and also applications. Now, if you look at a welding electrode, by the way, I have an example of an electrode here, an actual electrode, and this is how it looks. It looks like. So you'll actually find a number right here. So that's I think that's 60 E6013. Another example is this one. So we have this. If you can, okay, so that's right here. It has E6013. Okay, so let's discuss um, this notation. So for example, we have E6013. Then what does it mean? So E stands for an electrode, and 60, these two numbers right here, they actually correspond to a minimum tensile strength, of course, of I think that would correspond to the strength of the joint. Okay, tensile strength in KSI. Okay, so that's in kips per square inch. So um, if we have a steel bar of, let's say, A36, oh sorry, not this one. For example, we have a bar of A36, then that's 36. That is 36 KSI. Now this one can provide 60 KSI. Of course, I think that should, I mean, in common sense, that should correspond to a proper welded joint. Okay, so meaning that the joint is stronger as compared to the to the base metal. I mean, the strength of joint is stronger. Okay, so what is this 1 and 3? This next digit refers to the position. So welding position, how are you going to weld? So we have I think we have 1 for the general, and then I'm not sure with this, but we have this position right here, like for example horizontal, and we have vertical, and overhead. Okay, so it just means that, for example, this is my welding electrode. When you say horizontal, our workpiece would be laid in a flat, or let's say below you, and this will be like uh, welding like this. But when you say horizontal, its example is on the wall, along the wall, and this vertical, or let me draw it here. Let's say horizontal, it's like this is the electrode, and for horizontal, the welding is like this, and the vertical would be the welding would be like this. When we say overhead, meaning that the let's say this is our electrode, then this is our electrode, and here our electrode would be positioned this way. So meaning the welder is here and he's doing this welding job. Okay, so it's welding like that. Okay, so it's drawn something like a sword, but that's the electrode. Okay, so this 8 would mean, I mean this 8, this last digit refers to the type of of coating. Okay, so meaning if we have an electrode of, let's say, 70, uh, let's say any number XX, 70XX, then, or 7018 for example, then meaning that the joint, I mean the strength, minimum tensile strength, would be 70 KSI. Okay, so in the next video we will discuss the um, preliminaries, and then we go on to the codes and provisions.